Hey, everyone. I want to welcome you to today's session of this Minitab training. And today we are going to be considering hypothesis testing. You remember last time when we talked about the descriptive statistics, I mentioned that we cannot make conclusions in statistics unless we test hypotheses, unless we're able to, do the real statistical analysis. And after you have gotten your data, if you remember what I mentioned last time, you have to know whether the data follows a normal distribution or not. So once you are sure that your data follows a normal distribution, then the next thing to do is to decide which type of analysis do you want to use. Which type of analysis do you want to use for to be able to draw the comparison that you have in your data and then make conclusion. Now, hypothesis testing is one of the methods of statistical analysis. And in Minitab, the software that we're using, there are diverse methods of hypothesis testing, which include what we call the t-test. Even analysis of variance is also an example of hypothesis testing. So whenever you want to do a statistical analysis, it is important to set up what we call hypothesis for the basis of making conclusion for your work. Now, depending on the objective of your study, hypothesis generally is of two types. We have what we call the null hypothesis, which is designated as H0, and then we have the alternative hypothesis, which is called designated as HA. Now, the null hypothesis is the initial claim, and it is what you believe might be true about your data, about the study itself. So it is what is assumed to be true, all right? And normally, it usually states that there is no significant difference between two means drawn from different populations. You remember in statistics, what we are comparing in statistics, if you are comparing two different populations, what you are interested in there is the mean of the populations or the samples. So in statistics, the null hypothesis would tell, or we would usually say that there is no significant difference between the means of the two populations that you are comparing. That is what we call the null hypothesis. And then the alternative hypothesis will now say that there is significant difference, okay, in the means or between the means of the two populations that you are comparing, depending on the population. It can be more than two populations, it can be three, it can be, so depending on what you're comparing, the alternative hypothesis would tell you that there is significant difference. Okay, so let me show you inside Minitab software what we normally use to seek for a guide on how to select the type of hypothesis test that you want to use for your work. So just open Minitab. You can open Minitab software on your computer. Now, this is my own Minitab software. So let's go to, having opened the Minitab software, you can then go to assistant. You can see assistant on the menu bar. Just click on assistant. So when you click on assistant, you will see different types of assistants that you can seek for. All right. So let's click on hypothesis test. So click on hypothesis test, and then let's see what Minitab has to offer. Now, Minitab is able to give us three different types of objectives that probably you may have in a research study, okay? The first one, it says, if you want to compare one sample with a target, that means if your study is about just one population, one sample, and you want to now compare the sample with a particular target. With a target means like with a particular standard. Maybe you're working on a particular chemical, and then you're trying to test the effect of the chemical on something. And then you now want to compare the result of what you have gotten in your result on your research with the standard. Maybe there is a standard that has been reported as the normal effect of that chemical. So once you get your own data, and then you can compare your data with that standard that has been, that has been reported in literature. That is what you call one sample. You are comparing one sample with a target. And if you want to do that, there are different types of tests that you can use. We have one sample t-test. We have one sample standard deviation. We have one sample percentage defective. And then we chi chi-square goodness of fit. Out of all these four, one sample t-test seems to be the most common one. That is, if you are doing a research whereby you want to compare, you have measured the effect of a particular factor, and you want to compare the result with a standard that has been reported in literature. So you can use a one sample t-test for that. Now, let's go to the second objective. If you are comparing two samples with each other, you can also do what you call, there are different types of analysis that you can do. We have two sample t-tests, all right? If you're comparing two samples means you have two populations, and then you want to compare between the two populations and see whether this one has more, has more particular parameter than the other one. If you have measured some parameters on the two populations and you want to compare which one is higher than the other, which one performs better than the other. So you can then do a two sample t-test, all right? You can do a paired t-test. You can do a two sample standard deviation, two sample percentage defective, or chi-square test for association. Now, let me mention something about this chi-square briefly. Chi-square test is usually used for studies that have what's it called? Studies that have that are categorical in nature. If you're comparing categorical data, all right, so you can use chi-square t-test for that. So, and then if you want to now compare, you can use also two sample t-tests, for your, but like I said, the most commonly used one, if you want to compare two independent samples, you can use two sample t-tests. It is the most commonly used one, and then, but if your work is categorical in nature, you can use chi-square tests, okay, or for association. Now, if you have more than two samples that you want to compare, all right, in that case, you would have to use what we call a one-way ANOVA, all right? You can use a one-way ANOVA, which you can use for your analysis, and then you can use a standard deviations test. You can use chi-square percentage defective. You can also still use chi-square test for association, all right? If it is also more than two samples that you are comparing. So let us close this and let's go back to the manual and see what we have there. So that is how you can use Minitab to just do a quick check of the type of analysis that you want to use. So let's go straight to t-test, and then under t-test, which is if you're comparing whether one sample or you're comparing two samples, we can have two different types of t-tests, like I mentioned earlier on. There is one sample t-test, which I mentioned, explicitly, that it is usually the one that is used when you have one sample and you are comparing that sample with a standard. All right, it is not as common as the two samples t-test. For two sample t-tests, you have to use, you're comparing between two different sample means, okay? And which is the most commonly used one. So we're going to demonstrate how to carry out the two sample t-test, and then from there, we'll continue. So now the data that we have been using on fruit weight, I'm going to go back to that data. Let me open back the Minitab software. Now, if you remember the last example we did, we used this data, but for t-tests, I need to make this clear. If you are doing t-tests, the least sample size of each population that you are comparing must be 15. That means, for example, this mango plant, we have only 3 here, 1, 2, 3. That means we cannot use this. It's too small. It's just for us to, why I use this one earlier is for us to be able to just do as an example. But in a real life situation, if you want to do t-test, at least because it must follow the assumption of a normal distribution. So it means that the sample size, at least when you combine the two sample size together, they must not be less than 30. So that means each sample size should be at least 15. All right. So I created another data. All right. So this is another data that I created. All right. So this data tells us about just the same fertilizer treatment, a particular scientist who is working or who worked on the application of fertilizer on the plants, and then just on one plant. But now in this case, he used 2 different types of fertilizers. So, and then eventually he measured the number of fruits that the plants produce at the end of the experiment. So it has this number of the fertilizer. There are 2 different types of fertilizer that I use. We have the cow dung, and then if you go down, what you see the second type, which is the NPK fertilizer, the cow dung and the NPK fertilizer. So the cow dung has 15 different plants. He applied cow dung on 15 different plants, and then NPK fertilizer on another 15 different plants, making a total of 30 plants. All right. And then the number of fruits are also in front. So the second column represents the number of fruits. So we want to see how which of the fertilizer produce the highest number of fruit. That's the idea, to see whether the cow dung performed better or the NPK performed better. So for you to be able to draw this conclusion, you have to subject your data to 2 sample t-tests. 2 sample t-tests. So let's go back to the manual. So in the manual, all right, you have the same data there. So let's run through the manual. So the null hypothesis that you have to, like I said, before you do any analysis, after you have done, you have checked whether the sample has a normal distribution, the second thing to do is to draw up hypothesis. So in this case, our null hypothesis states that there is no significant difference in the number of fruits between the 2 fertilizer types. That means the 2 fertilizer types are not, the effects are not different from each other, are not significantly different. Significantly different from each other. That means there is no difference in the number of fruits. Whether you apply cow dung or you apply NPK, you have the same results. Then the second alternative hypothesis will now say that there is significant difference in the number of fruits between the 2 fertilizer types. So the next thing to do for us to be able to do this is to go back to Minitab. So let's go back to Minitab where we have the data. So click on Assistant. So when you click on Assistant, go to Hypothesis Tests. Click on Hypothesis Tests. When you click on Hypothesis Test, then go to the type of the one that you want to do, which is the 2 sample t-test. So click on 2 sample t-tests, right? So we have this will come up. So Minitab is going to ask, do you have both samples in one column? And in this case, the answer is yes. So we have both samples are in one column because we have both samples under the column fertilizer. If you have them on separate column, you can also select here. Just drop this, click on this arrow down, and then you can see that you have an option where you can say that each sample is in its own column. But in this case, the samples are in the same column. All right. So if you have selected that you have the samples are in one column, the next thing is to do is to now put the column where they should be. So the sample data is the number of fruits. So if you click here, let me just delete this. Let's see, delete this. So if you click here, you will now go to the left-hand side and double click on the number of fruits. So the IDs, which is what represents what we are doing, the sample that you want to compare is the fertilizer. So just double click on the fertilizer here. It will enter inside the space there. So you will now go down and then select what other things you want to do. What do you want to determine? All right. Is the mean of cow dung greater than the mean of NPK? Is the mean of cow dung less than the mean of NPK? Now, is the mean of cow dung different from the mean of, that is what we're interested in. Our interest is to see whether there are differences, the significant differences. That's what we do in statistics. Significant differences, does it exist between the two samples that we are comparing? So in this case, we want to compare whether there are differences between cow dung and then that of NPK. Then you have to select a threshold level, which is called the alpha level. In statistics, alpha level represents the level of probability that you are using to make your conclusion. And usually 95% is what we use, which is also like 5%. So it is 0.05. That is the level the least that you can use. You can also use 0.01 depending on your field of study. You can set your threshold to be 0.01 or 0.001, meaning that if it is less than or equal to this 0.05, then you can assume that there is significant difference between the two samples. So we have to select our alpha level to be 0.05, which is the same thing as 95% confidence level. So I think that is all. So you can then click OK after that. So let's click OK. So Minitab is going to produce the result. Now let's go to the result and see what we have. So you can draw down this curtain. So in this, you will see that two sample t-tests for number of fruits by fertilizer. So, and then the t-test is able to tell us that, yes, we have the mean of cow dung is significantly different from the mean of NPK because the p-value, which is the probability level, is less than 0.05. And you can see the probability level is somewhere here, which is less than 0.05. So it means that the difference between NPK and cow dung is statistically different or significant. Okay, so if you come to this right answer, you see the summary of the descriptive statistics. The sample size of cow dung is 15. Sample size of NPK is 15. The mean value is this. The 95% confidence interval is this. Standard deviation is this. And then so the difference between the two is this. And then the Minitab is telling us that the difference is significant. Let's run through the comment that we have also in the Minitab. He said, you can conclude that the means differ at the 0.05 level of significance. All right. So Minitab has been able to give us that conclusion. Okay. So having run the analysis, Minitab also gave us the conclusion of the analysis. Let's move down and see whether there is any other thing that can be of interest to us. Minitab also plots some charts that might be useful for you if you're interested in them. But most importantly, let's check what we have here. So Minitab says the two sample t-test for number of fruit by fertilizer. This is like a report check or report card, you know. It says that the data, there are no unusual data points. The data is normal, all right, because both sample sizes are at least 15. So normality is not an issue. You can see it is written there clearly. The sample size is sufficient to detect a difference between the means. So Minitab is able to give us some kind of diagnosis of the data, even after running the analysis. You can see how beautiful Minitab can be in testing the hypothesis of our studies. So this is how to do a two-sample t-test, okay? And you can bring up any examples also if you're comparing between two different populations, and then you find out that the data is, if you have run the normality and the data is normally distributed, you can run a t-test to compare between the two samples. If it is one sample, like if it's just only cow dung that we have here, if it is not, if there is no other NPK fertilizer, then we can run a one sample t-test. Let's see whether we can just, let's go to assistant, hypothesis test. You will see that we may not be able to do that because we have two samples, but let's click on one sample t-test, all right? So then in asking us, where do you have the data? So just double click on number of fruits. What target do you want to test the mean against? Like, you know, I told you that if you're doing a one sample t-test, that means you are comparing the mean of that population with a standard. So you have to mention the standard here. You have to state the standard. Let's say if the mean, the standard mean, let's say the standard mean is 4.05, for instance, and the mean of your own population that you are going to get is 6 point something. So Minitab is going to compare whether the 6.0, whatever that you get from your own study, is significantly different from the standard which you have set as 4.05. So you can then select here, is the mean number of fruits different from 4.05? So you just click on 4.05, then select 0.05. So let's click, let's see whether this is going to come up. All right. So Minitab was able to do this because Minitab did not consider the fertilizer as a factor. So he just treated the number of fruits as a factor on his own. So he's now comparing the mean of the number of fruits with the standard that we have set. So not comparing between two different types of fertilizer. So it's just for you to know that, you know, Minitab just assume that, okay, your interest is just one sample and you are comparing that one sample with a standard because you selected one sample t-test. If you had selected two sample t-tests, it would have brought up that option where you can choose the fertilizer as, you know, the samples that you are comparing, okay? So in this case, you can see Minitab says the number of fruit is not statistically different from the target. So because the mean, look at the mean here, the mean is 3.933, and we set the target as 4.05. So Minitab says 3.933 is not statistically different from 4.05. So you can go down and check the other things you have there and then see whether, so you can also see the checks here that the data is okay, it's normal, you know. So this is how to make, you know, to draw conclusion if you are comparing either one sample with a standard or you are comparing two samples or two different populations together. You can use these hypothesis tests, okay, for your study. So this is where we're going to stop, and we'll continue with the hypothesis testing using one way and over and the other types later on. So if you have any question, please don't forget to pen it down. So when we have our interactive session, you can always bring up your question. So thank you very much, and I wish you a wonderful day ahead. Bye-bye.